and Director of LPSC at ISRO, is a leading expert in cryogenic engine design, propulsion system analysis, and large mission project management. Now I request Dr. V. Narayananji to kindly address the gathering.
Start. Excuse me? Next slide back, okay. Very good afternoon to all of you. It's a great privilege to be in this important Bengaluru Tech Summit, in which I think a lot of industries, academia, and industrial partners are here. So I will be just maybe in another 20 to 25 minutes, give a glimpse of India's Space Vision 2047, technologies, challenges, and way forward. This is the topic I have chosen. So in my talk, I will give the major accomplishments of Indian space program over last 63 years, and Indian Space Vision 2047, also space sector reform and the commercial aspects, what we are targeting. I think you all know the Indian space program was started in the year 1962, and 1963 was a major milestone. November 21st, 1963, we had the first tiny rocket launch from Indian soil, and that rocket was given by none other than the USA. And the payload, a sodium vapor lamp payload, that was given by France, and the entire thing was assembled in a church building, and we accomplished the tiny rocket launch. And from that was the first major milestone, and recent major milestone was July 30th. We had a very, very important mission called NASA ISRO Synthetic Aperture Radar Satellite Launch. 10,300 crore USA JPL has invested to build a payload called L-band synthetic aperture radar payload and an antenna. And an equivalent payload was built by India. And the entire satellite was built by India and successfully launched by Indian launcher in the required orbit. And today the satellite is working well. That is the type of growth of the country. And 15th August 1969, Indian space program was formed. And 1969 was a very important year. I think Neil Armstrong landed successfully on the moon and came back safely. And we were truly 60 to 70 years behind the advanced countries, carrying rocket at that point of time in bicycles. And 1972, the Department of Space was formed. And up to that, initially 10 years, we were with the Department of Atomic Energy. And now the entire space activity is with the Prime Minister of India, and we have got ISRO carrying out the R&D activities related to launcher, infrastructure, and the satellite-related activities. We have got autonomous bodies and the commercial wing, the NSIL and Antrix, also the space, in-space, the authorization and promotion body. And we have got 43 offices located in 22 locations. We are strongly supported by 450 industrial partners, and 130 academic institutes are participating in our program. Now the entire 63 years activity is presented here. From 1963 to till today, we have accomplished something around 4,000 plus sounding rocket missions. Almost 70% belongs to India. And 6 generations of launches we have developed. The first launcher was successfully accomplished in the year 1980, capable of placing 35 kg in the low Earth orbit. Today we have got the Bahubali rocket, Mark III, capable of placing 10,000 kg in the low Earth orbit. And we have accomplished something around 103 launch vehicle missions. And in the area of satellite, the first satellite was built with the support of USSR in the year 1975, April 19, we launched. From that till now, 134 satellites we have conceived, built, and launched. The heaviest satellite is the communication satellite, high throughput communications, GSAT 11 satellite, 6,000 kg satellite right now, fantastically working in the orbit. And we have accomplished lot of scientific missions, and the space sector is growing exponential. And we have also placed in the launched 433 satellites of 34 countries from Indian soil. And in the area of application, 1st August 1975, we demonstrated mass communication using a satellite signal from US satellite HS-6 and keeping 2,400 television sets in 2,400 villages of 6 states. From that, till today, there are 50 applications. And today, I cannot imagine a country, imagine a Bharat without satellite technology and space application in the area of Earth observation, SATCOM, NAVIC application, disaster warning and mitigation, and strategic application, including recent Sintur operation to ensure the safety of the citizens of Bharat. We have contributed. And space science, we have accomplished 10 scientific missions, including Astrosat, which has completed just 10 years of service, Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, Mars orbiter mission, and Chandrayaan 3, you all know, 23rd August 2023 was a historic day. India is the first country and only country till today soft landed near South Pole of Moon, and lot of accomplishment in the scientific area. A country which started with 60 years behind advanced countries, moving rocket parts in bicycle and satellite in Bulla car today. 10 places we are number 1 in the world. Chandrayaan 1 finding water molecule on the moon, along with USA we are number 1. Mars orbiter mission, 68 crore kilometers we have traveled and we have accomplished successfully. And till today, India is the only country and first country accomplished Mars orbiter mission in the first attempt. And using a single rocket, the Russia, first time 1957, placed the Sputnik in the orbit. Then they had the record of 37 satellites. And we Indians accomplished more than 100 satellites, 104 satellites using a single rocket and made record. That was yet another history. And Chandrayaan 2, we have placed a orbiter. We have placed a orbiter in the moon orbit. The best camera available in the moon orbit belongs to India. OHRC 32 centimeter resolution, and the best photographs belongs to India. We are number 1. And solid propulsion, just with the testing 2 solid motors, we have accomplished the Mars 3 mission. Till today, 8 successful missions are done. All missions, successful missions. We have completed all 8 Mars 3s were successful. And Chandrayaan 3, you all know, it was a historic moment. And cryogenic propulsion system was denied to India. And thanks to those countries who denied the technology, today, 3 propulsion systems we have developed, and we have made 3 world records in the propulsion system, cryogenic propulsion system development. And we are inching forward to make 1 more world record in the cryogenic propulsion in another 1 or 2 years. And global leadership. And you know, when Honorable Prime Minister Narendra Modi ji took over as the Prime Minister of our country, we got guideline and we have built a satellite, and a 1000 kg communication satellite was built by India and launched and donated to South Asian countries. We are building a G20 satellite, and NISR, I already explained, we are working with Japan for a Lupax mission, which is a large lander, heavy lander. Chandrayaan 3 lander was only 1600 kg. This will be a 6800 kg lander. And Chandrayaan 3, we had 25 kg rover. Here we'll be having 350 kg rover. We are working towards that. And we are also working with supporting other neighboring countries for the space program. Recent accomplishments, we have recently completed the docking experiment, and India is the 4th country successfully completing the docking experiment in the world. And the first launch, rocket launch was done, launch vehicle launch was done in the year 1979, which was a partial successful mission. This year, January 29th, we had the 100th launch. We have successfully launched and made golden letters. We have written the space history in the country. That 100th launch was a successful launch. Axiom program, we have sent Gaganyatri Subhashnu Shukla, the first Gaganyatri to be from India to go to space, International Space Station, and India has contributed to ensure his space safe travel. And NSR, it was a very, very successful story that today the satellite is fantastically working. It is going to work under 6 to 7 years. And recently we had a very important accomplishment. the heaviest communication satellite lifted from Indian soil, 4,400 kg communication satellite for strategic application. It was lifted off and placed successfully in the orbit this year, this month, 2nd. And then Gaganyaan program, we are working. This is a very, very technology intensive program. You can understand till today around 80,000 tests are completed, and we are inching towards the actual mission by 2027. Before that, we have to accomplish 3 uncrewed missions. And India Space Vision, Honorable Prime Minister has given a clear direction and roadmap. And we are working on our Gaganyaan program. We are working on huge rocket development called our NGLV from 35 kg from 1980. Now we are working towards a 80,000 kg capability rocket. It is going to be a 40-story height rocket for a crewed lunar mission. We are working on a space station. It will be a 52-ton space station. By 2035, we are going to accomplish this, and first module will be placed in orbit by 2035. We are working for Chandrayaan 4 mission, which is going to be a sample return mission, and by 2040, we are targeting crewed lunar mission. And by 2040, I can tell, a country which started with old bicycle game, we will be in par with any other country in terms of rocket, in terms of satellite, in terms of application, in terms of human spaceflight capability. And this is our Gaganyaan roadmap. We are going to have a lot of activities, and this is the configuration of the space station. And Chandrayaan 4, Chandrayaan 5, already I have explained. And we are going to, by 2040, we are going to land on Moon. This is the program on which currently the work is going on. Towards that, lot of development has to take place, including new propulsion systems, LOX-methane propulsion system development. And Venus orbiter mission, we are working towards that. Mars lander mission, government is going to approve this program. We are improving the payload capability of Mark 3 by 25% without increasing in even 1 paise. We are working on a 200-ton LOX kerosene engine. It is in the advanced stage of development. And we are working on reusable technology, air breathing technology, and recovery-related studies, and new engines, combined cycle engines, which the aircraft can take off like aircraft and followed by rocket engine reducing the travel time, and new propulsion system for spacecraft. And lot of R&D activities are going on, including quantum communication, reusable engines, air breathing engines, new propulsion systems, then ECLSS, microgravity related experiments, artificial intelligence, atomic clock, lot of developments taking place. And we have got our own roadmap. Right now, 57 satellites are in the orbit. This number is going to be increased to 3 times in another 3 years time frame for serving the common man of the country. Coming to space sector reform, when we talk about the capability enhancement to 3 to 4 times, and today when you look at 63 departments of Government of India using space data, and all state governments are using space service. If I have to talk about application, I think that will take 2 hours. I am not going to venture into that in terms of television broadcasting, telecommunication, disaster warning and mitigation, ensuring food security, water security, real-time connecting the train, Navy applications, potential fishery zone monitoring, weather forecasting, and ensuring security and safety. Lot of application, and that means ISRO alone cannot do this job. Government has rolled out the space sector reform, and today, right now we are rolling out our own rockets to private sector, and the first rocket PSLV coming from industrial consortium, we are targeting the launch this finance year itself. And of course, PSLV already, SSLV technology is also transferred to HAL, and we are building 2 more launch. Right now we are having 2 launch pads. We are building 2 more launch pads, one in Sriharikota, 3rd launch pad, and 1 more launch pad near Kulasegarapatnam. And Honorable Prime Minister has given the direction. Right now our capability is launching 12 to 18 launches per year. We are going to take it to 50 launches in another 5 years time frame. And till now, there are 14 dedicated commercial launches we have done. 433 foreign satellites we have placed in orbit using Indian rockets. And next month, we are going to have a 6,000 kg communication satellite of other country. In commercial way, we are going to launch from Indian soil. And this is the Bluebird satellite, a 6,000 kg communication satellite is target to be launched. And we have developed a lot of technologies, indigenous sensors. These things are going to be transferred to industries, and so much technology transfer is taking place from the space activity to other sector. You can see the number of technology transfer agreements, what is done over a period of time. And our target, when we started the space program, based on the vision of the father of Indian space program, we had to serve the common man of the country. Today, yes, we are serving to some level, and it has to be taken in a big way. At that point of time, we were not talking about human spaceflight program, but then that is a vibrant program. Another thing is, we were not thinking about the commercial aspects, but today, when we reviewed the space economy, global economy, our share is hardly 2%, $8.4 billion. This we want to take it to the level of something around 10%, 8 to 10% by 2035. And it is very easy to say, but then very difficult to achieve. And we are putting a vibrant system involving almost lot of startup companies. You can understand, when Honorable Prime Minister rolled out the space sector reform, hardly 2 to 3 startup companies were working. Today, 330 startup companies are working. And we are quite confident of achieving this target. That means a country, when we got independence in 1947, you all know what was the stature of the country. 97.5% people were below the poverty line. Today, we are economically 4th in the world and inching towards achieving 3rd position, maybe in another 8 to 10 years under the visionary leadership of our Prime Minister of India. And you take health sector, when we got independence, average life of Indians were just 32 years. Today, just 2 months back, it has become 72 years. That is the contribution of the health sector. You take education sector, when we got independence, the literacy level in the country was hardly 12%. Today, it has become 80% with outstanding institutes like IISc. I think the professor is going to talk about IISc and its contribution in quantum and other areas, and IITs, IIMs. And I am one of the proud product from the first IIT, which was started on 18th August 1951. And that IIT has taught me not only academics, it also has taught how we got independence in the country. You know, IIT Kharagpur was started in a place where the Khijili detention camp was there in memory of the freedom fighters only. The IIT was built there. And you should understand, I don't know how many of you have gone there. When you go there, you will understand cells, fully closed cells with 58 centimeter length by 28 centimeter height, that much opening. Please understand, somebody is put inside. Who is giving food, who is giving water, nobody knows. And another type of cell, 3 side closed, 1 side opened, outside lot of snakes in the forest, and no light, no water, no food. I think the independence was yearned not just like that, it was with great sacrifice. And today the country is built by lot of people, and it is our responsibility to contribute for making this country as a developed country. Towards that, the Indian space program is working towards that, achieving equal stature of any other developed countries by 2040. And we are a vibrant nation, and surely the youngsters will contribute towards that. Thank you, Jai Hind. I am ready to take maybe 1 or 2 questions. Yeah, please.
Good afternoon, sir. So I'm feeling blessed to talk to you and ask this question. I'm Shashwat Sharma. I'm an AI engineer at Alisum Global Services. I primarily work in the space of agentic AI. I wanted to ask you what role can agentic AI plays in our 2047 mission in terms of software proposals?
You are not clear. Please come. You are not audible. Maybe echo. What is your question? First, you come to the question.
So my question was, what role can agentic AI play in, in like combining the agentic AI and space programs, and what role can agentic AI can play in achieving the mission 2047?
Electric? Sorry, I'm not.
So agentic AI.
AI. Say, let me give one small example. 35 years back, when we were students, there was no laptops, no computer, nothing. And we were all working in one condition. And at that point of time, we never thought the computer revolution is going to take place like this. Today, without computer, nothing can be done. Am I right? There was a time without computer, even man was into moon with small systems. And same case with AI technology. Today, AI technology is everywhere. And in space also, lot of applications, AI and robotics, these are all the two important areas. But when you use AI, one should be very careful. You should know where to use, where you should not use. I am hearing now everybody is talking about AI, but then we should be very careful, smart enough, intelligent enough to use in the appropriate place. And AI is going to play a crucial role. In space sector also, it is going to play a crucial role in lot of areas.
Thank you.
Thank
So
you.
much, sir.
Okay, thank you. Thank you, gentlemen. Actually, I have to take a flight to Delhi, and before that, I have to go to my office. Because I made a commitment, I thought I should not go back from my commitment. I came. Thank you for the patient hearing. Thanks a lot.
Many thanks to Dr. V. Narayananji. May I request Dr. Gopichand Katragada to kindly present our respect. I request Dr. V. Narayananji to receive this honor. Dr. Gopichand will be our next speaker as well. Our next speaker for the day will be Dr. Gopichand Katragada. He is CEO, Mail-in Foundry. Gopichand Katragada is the founder and CEO of Mail-in Foundry, an independent director across leading firms, and former group CTO of Tata Sons and MD of GE JFWTC. He is also a chartered engineer from the UK. May I request now Dr. Gopichand Katragada to kindly present his views.
Thank you very much. It's a pleasure and privilege being here and talking about topics which are dear to my heart. And we'll walk through few areas of how you take lab-based projects to the market. And this is very critical. This is very important from a standpoint of where we are in India. A lot of projects do not make it beyond the labs, and which is natural. However, the percentage needs to increase. So I'll just get started sharing thoughts with experiences to back it up. And my presentation is titled Bold Moves, Deep Impact. And there is a reason that I picked that, because many times in India especially, we try to make safe moves. And also we look for broader inclusive impact. While that is important, you look at innovation and what we are doing in the labs. If you aim for deep impact, even if it is inclusive, you aim for taking a technology to the rural areas, focus on that. Do not try to make it cover everything, and that's where we lose the way. And that's going to be the theme of my presentation. So examples from my experience is what I'll share. GE being an example. Is this on? I can use this? Yeah. GE being an example which I can take very comfortably. I've spent 12 years in GE, and we have launched many products which have gained not $1 million, not $100 million, but even billions of dollars, all developed in India. GE John F. Welch Technology Center used to often be referred to as the largest R&D center GE had outside of the US. But can I share with you, it was and is the largest R&D center GE had anywhere in the world, including the headquarters. Right? And very few people know this. We were, at the time I was there, 4,500 researchers and engineers, and nowhere in the world we had such a group of people producing technology. Every technology I'm showing you on this chart, from start to end, was built in India, right? And starting with the lab and taking it into the market and producing significant revenues, of course, but making an impact which was deep. I'll give you one example in the interest of time. In India, we have wind regimes which are 7 meters per second. And those wind regimes are classified as low wind regimes. So no one else would work R&D to create wind turbines for this class of wind. Because the rest of the world where wind turbines were placed, the wind turbines were running in regimes of 12 meters per second. So why would I build something for 7 meters per second? But for us, it was a necessity. While we talk about wind in India, we do not realize that there is a specific wind corridor. And that wind corridor has a limited amount of power it can generate. And even that only if you can tap winds of 7 meters per second. Right? So we developed that in the lab and then into the field. And it requires significant amount of what I would call not the fundamental IP work, but fundamental engineering work. Being able to take the wind blades into much larger diameters. So we produce the largest wind turbine blades so that we can take as much wind in a low wind regime, which meant that the bearings had to take more load, which meant that the towers had to take more capability in terms of vibrations and wind impact. And so this turbine which we produced for India, eventually what happened was that while we grabbed the Indian market, and many of the turbines that you will see while you're going in Chitradurga and anywhere else are our turbines from GE, it also grabbed the global market because the 12 meters per second wind regimes were taken. So now the market was only for the low wind regimes because rest of them were populated with a 20-year life. So hence we were able to produce $1 billion, $2 billion, $3 billion a year with this wind turbine, which I'm proud to say my team produced in India and entirely. So we have the capability of doing the research, taking it into the market. I'll give you one more example and something smaller. The wind turbines are large, the blades are large, it takes a lot of wind and a lot of engineering. One more engineering example, and then I will talk about research as well. This is an example of a baby warmer. When babies have preterm birth, they are susceptible to many things, including jaundice, but also they have to be kept warm to keep them alive. And the lullaby baby, the giraffe baby warmer, which you see on the extreme left, was very expensive for the Indian market, and it was not affordable for most hospitals, and so it was not being used. So babies would be put outside in the sunlight to keep them warm. And that meant that they were exposed to radiation which they need not be exposed to if you just want to keep them warm. So we developed the lullaby baby warmer, much simpler. We did not take the giraffe and break it down. We started ground up. We got the nurses to come to our center, and they also told us what they didn't like about the giraffe baby warmer. So if you can see, the way of placing the baby there is in the narrow way. So they wanted the wide way to place the baby, and you see that's what we accomplished. We took the warming element and pushed it off the center so that it was easy to place. And the key thing is, you might think, okay, India, we can go low on quality. But in India, the way we are showing that baby, that's not how it works. One baby there, in the hospital, 3 babies in one tray. So you have to achieve uniform heating throughout, right? So we had more onerous responsibilities of making this baby warmer click. And of course, what we developed included, for example, all the elements that you see, like the legs of the baby warmer, were arms of a chair. So that is, in a way, innovation. I think the book you're being given is Do More with Less. So that chair handles, if you can use, the volume element has already been taken. So you can buy something which has been developed and mass produced. So you are not worried about the cost or the design. So those are the nature of innovations, but the IP comes in when we said, okay, this is warming, but how about jaundice? How about bilirubin, which needs to be tackled for a jaundiced baby? So we separated out the LED lights. In fact, we were the first to create LED lights for jaundice, and you see that on the extreme right. We used to bring it over the babies when required for treating babies with jaundice. So these are all the innovations which went from lab to market. They were bold moves because you can always say, no, sell the giraffe. It was a bold move to say we'll make a lullaby baby warmer. And it is an impact because you know exactly what you're targeting based on what the nurses are asking in the hospitals, in the region you're in. So in order to do this, I'll give you again more detailed examples very quickly. But you need to use a framework. What framework you use, it's up to you. But you need to think through all the elements of what it takes to make something developed in a lab to go into the market. This framework is generic. It's a balanced scorecard framework. So in order to think about the market, you need to think about the stakeholders. You need to think about the product. You need to think about the profits. You need to think about the revenue. But if that is all that you think about, you're not going to be as successful as you can be. So you have to first start with what kind of people I need. Who are the innovators? How can I create technology which will matter? And then what are the processes I need to excel at? In innovation, you might think there is no process, but innovation is not just the idea. It is the ability to take something new into the market. That is innovation. So you will have processes in the journey. Customers, you need to understand the customers and what they need, and only then you will get those financial benefits. So unless we think like that, what is in the lab will remain in the lab. And various examples for various organizations that I've been in, and I'm sure that in this audience, there are people with labs. So this is an example of a lab. It's a small lab, 20 to 30 people. How do you think about the balanced scorecard and taking innovation into the market? So build people with technical proficiency, ensure that they understand innovation, but also have process like Six Sigma. Make sure that we are working on critical programs and not projects, not tasks for sure. That's the only way you can get to innovation. Similarly, on the IP side, we built a large team, the largest in the world producing IP analysis and patent output for GE, but it was the largest in the world. Similar kind of thinking for that. Large size engineering team, 2,000 people. And still, you can think about what is the focus, what is it uniquely that we'll do here. And that's how you build things for the market. And yeah, I'll just mention that from an engineering standpoint, each area that I have listed here, engineering foundation, engineering mindset, and execution, there are a couple of areas where we do very well in India. There are a couple of areas where we need significant improvement. And unless we talk about that, we will always be only sloganeering. And to avoid sloganeering, I'm going to say engineering foundation, we are extremely good, better than the best in the world on theory. Right? But when it comes to building that engineering foundation, based on hands-on experience, based on being comfortable using our hands, based on doing engineering approximations, we are far behind where we need to be. So if we need to win this game of taking lab to market programs, we need to get hands-on. Engineering mindset, we are very good at components. We are a long way behind on systems. Execution, we are extremely good when it comes to being frugal and cost conscious. You would have heard many stories. But we do not write anything. We do not document. We cannot pass on the engineering to the next generation. So we need to get better at documenting, writing it down, and making sure that we are collaborating with ourselves. Because when we write things down, we will be able to collaborate with ourselves over the years. Because when you're in the depth of things, you're a different person than when you come out. Later, you will not remember the things. But most importantly, you will be able to collaborate with your teams. You'll be able to collaborate with the future teams. That is very critical. We are very poor at documentation. We think that is not part of the job. You have to document as part of the jobs. I will not talk about innovation in detail. That's a whole session in itself. But 3 areas I will say is that we are all very comfortable with ideas. Ideas is the beginning of a journey. That's where you will get stuck in the lab if you think ideas are innovation. Ideas are the beginning of the journey. 90% of the time you will be spending on nurturing a specific idea which you have picked. So be cognizant about the fact that you have to think about that. But also important, when you are the most successful, you have to change. Otherwise, you will be a one-time innovator. And also, it is important to note that if you want to take something from lab to market, you have to understand your technology. It's not enough. You have to understand what are the technologies around it. Otherwise, you will be using a silver bullet, and silver bullets do not exist for all problems. So you have to be able to combine your technology with other technologies, but also you have to understand the trends which will provide a market for your technologies. You have to convert those trends into market needs today which has not been met completely, and tomorrow which you can anticipate. And that is the way you will be able to keep ahead of the game and make sure that your technology is addressing something which is useful. Again, I'll close with a couple of examples from other places other than GE as well, including my current company, dear company, Mylan Foundry. The Tata example, we wanted to bring together companies and do really significant research, which we did by bringing teams together at the Tata Sons level, by bringing teams from various companies as well as adding our own members. But also we did not hesitate collaborating in India with IIT Kharagpur or IIT Madras, but not stopping there, but going global. And there I'll make another point. If you take baby steps, it will not work. Do not take baby steps, make bold moves. We straight away signed deals, multi-million-dollar, multi-year. Even after I was no longer with Tata Sons, nobody could stop the research which was going on. And that has significantly helped the Tata Group, be it hydrogen fuel cells, be it the gut health and the fructo-oligosaccharides that Tata Chemicals produce, be it the ability to understand the market and understand who are the influencers through understanding the network influence. These are all things that come from multiple universities. And specifically, IIT Kharagpur was for manufacturing, IIT Madras was for materials. My current company, again, we are in the same journey. We were ahead of the time in 2019 when we said we will unlock value from AI. We were also significantly ahead of our times when we said that the value that has to be unlocked in the cloud will be done by many players, many big players. So we will unlock value by leveraging the cloud and being the best, but we will differentiate on the edge. What is the edge? Doing AI in the automotive, doing AI in the phone, doing AI on the factory floor, without necessarily having to go to the cloud for inferencing. But training we'll do in the cloud, deployment we'll do in the cloud, we'll report in the cloud, but we'll not inference there for various reasons, latency, privacy, and so on and so forth. So we built that edge AI stack to be able to run significant AI modules on small compute, dealing with unstructured data like video. And on that, we built technology elements, which is the ability to extract intelligence from incoming streams, whatever the stream might be, if it is video, audio, or text, and also add intelligence from the outside world. So Fovea GPT extracts intelligence, Fovea Stream adds intelligence. We built on top of that several products. These products are in the market. We know that Mahindra uses it in the XUV 700, uses it in Scorpio N. And they're a company which allows us to talk about them. There are other companies who use it with millions of people, and I can't take their names, but they are global OTT players. So these are in the market and getting used. But our journey has just begun, because we have examples of large-scale use. We have to multiply that. It's a tough journey. You do not know what will happen tomorrow. And lab to market, being bold, having deep impact, means that you are comfortable with that. You are comfortable that tomorrow you might not be there. Tomorrow you might be the greatest hero, your company might be the greatest hero. But what you need to be doing is having the resilience to take it there. As an example of something which is really lab, is an ability to do chronic inflammation measurement using non-invasive measurements, using AI for getting that chronic inflammation metric, right? And this is today very desirable to be able to say from a wearable, say that 5 years later you're going to have a chronic disease, right? And we have produced that, patented that, but it takes a long journey getting it into the market. These, we have got it into the market, being able to take AI into the factory floor. And I'll end with this slide, which is to say all of you, when you're thinking about lab to market, being bold, having a deep impact, you need to think about what are your technology stories. Because you need to be storytellers. You need to be able to sell it in the market. But your stories must be informed by the market. You must be informed by the trends. What are our unique market needs in the markets that we serve? Right? That is where we can make a difference. If you're already running and having good revenues, a technology like AI, do not think about can I increase by 5%, 10%, can I double my revenue? Are we empowered enough? If you're in a team, not directly the CEO himself or herself, then you need to make sure that you're empowered. And are there areas, if you're an MNC company and you're running a R&D lab here as a GCC, nothing wrong with it, but make sure that your teams are empowered, working on meaningful things, and also working on things for India, not just the headquarter market. Right? So with that, I thank you for your time.
May I request Professor Arindam Ghoshji to kindly come up on stage to present our token of gratitude to Dr. Gopichan Katragada. Thank you, Dr. Gopichan Katragadaji, for your wonderful presentation. And our next speaker will be Professor Arindam Ghosh. Professor Arindam Ghosh is professor at Department of Physics, Indian Institute of Science, researcher in experimental condensed matter physics, nanoscale electronics with semiconductors, physics at ultra-low temperatures are his area of specialization. May I request Professor Arindam Ghoshji to kindly present his views. Ladies and gentlemen, please welcome him with a round of applause.
Thank you. You can hear me, right? I've got 15 minutes, so I'll get started quickly. I'll be talking about a technology which is far newer than space or computing, etc. So what I'll do is that I will take two course actions. One is break certain myths about quantum technologies, and the second is I'll tell you what is happening in Karnataka at this stage, also nationally, so that we understand where we are going with this. First, the myths. First myth is, let me just check. No, this one doesn't work. All right. Yeah. First thing is, let me see if I can change it. No. You have to change it then, because it's not connecting from here. Quantum technology is not just quantum computing. Quantum technology has three aspects. It has got quantum communications as well as sensing. Of course, quantum computing does certain unique. Let me just check. Okay. Right. Okay. I'll try to change. Yeah, works. Wonderful. Thank you. So, the quantum computers are unique in many applications. They do certain applications exponentially faster, but quantum communication allows you to communicate without the danger of getting overseen or over-listened. And the quantum sensing is another area which actually has applications all throughout the social life. So quantum technologies is actually a three of these taken together, not quantum computing alone. And some people, the second myth is that the quantum technologies is about a technology of the future. That's not true. For example, okay, I mean, there are many numbers that even if you do not take that into seriousness, quantum computing companies are already making money in the market. If you see the way the quantum computing companies increase in 2025 alone, there's about 40% increase in the overall revenue that quantum computing companies are generating. Okay, quantum sensing is something that you need to be aware of as well, because quantum sensing allows us to make certain devices that serves a purpose that simply is impossible with the current technologies. For example, if you want to measure magnetic field, extremely small magnetic fields, then magnetometers can be created, and many of these technologies are already laboratory tested, and production and the field use has started. Now, what can we do with these technologies? I'll just give you one example. If you make an extremely good magnetometer, you can make your aircraft fly in a GPS denied zone, because what you can do is that you can make measurements of small variations in the Earth's magnetic field to know exactly where you are. So you can actually take your aircrafts, you can take your drones, etc., in regions where you are not able to, or you are GPS denied. So you see, there are 2 or 3 important aspects. It also means that it could be useful in navigations. It also has a strategic aspect in terms of public safety and defense. And now these kind of products are available in the market. There are companies like which actually work very closely with AI and in noise mitigations and so on and so forth. And there are other companies like Q-Control, for example, and you can get these products which can actually measure tiny magnetic fields, and you can board them on the aircrafts and actually make some serious applications. Good. So this is where I would like to say that this is not a technology of the future. It's actually technology of the present. Now, the goal is where this technology is going to go in terms of market impact. What about the revenues that we are talking about? Typically, it is projected that in about next 10 years, we are talking about $1 trillion of economy that is being generated under the quantum umbrella. And the 5 major areas, you can see finances, healthcare, telecom, materials, and transport. Finances take the maximum, is projected to be the maximum. So it's really one is looking at $1 trillion economy in the next 10 years or so. So the question is, what are we doing with it? India as a country and as an ecosystem. So of course, the National Quantum Mission has started a 6,000 crore program about earlier last year. And in addition to that, what Karnataka has done recently, Karnataka has become the hub for quantum computing. IISc, Indian Institute of Science in Bangalore, is the quantum computing hub, which will oversee the development of quantum processors in the country. Some of the core hardware of quantum will be generated in this place. And based on that, earlier this few months ago, Karnataka Quantum Mission has been launched with the announcement of a quantum city as such, and a quantum city has been awarded a land and also a seed funding of nearly 1,000 crore. And the goal of the quantum city is to have a market impact of about $20 billion within about next 10 years or so. So that's the question. How do we achieve that? Is there a realistic way that the local market can actually reach to that kind of a value? Okay, so why this idea of what is called a quantum cluster? This is what quantum technologies in quantum city is going to look like. So typically, Karnataka has one of the best, if not the best, cluster of deep tech, high quality educational institution, and the necessary ecosystem of commercialization. So we are already the hub for quantum computing. We have 6 or 7 world countries' best educational organization, and we have the deep tech ecosystem as well as government regulatory policies. With this, we would like to build a system where we have got services, the quantum services, where you will have a quantum data center, for example, which will be offering services into the public through the cloud. We will have manufacturing zone, infrastructure, and as well as startup ecosystem, as well as export quality products. This is the overall theme of Quantum City that has just been announced by the government. Okay, So we are, as far as the education is concerned, we have been leading the education, quantum education in the country for some time now. IISc started the first quantum MTech program in the country. Oh, sorry. In addition to that, we have the Quantum Research Park, which is giving money to the local colleges and universities to start their own in-house quantum program. And now the National Quantum Mission, the entire education, undergraduate education in the quantum area is led by IISc. And so we really have the experience and the mechanism to how to teach people the next generation technologies in the quantum area. Okay, but then how to achieve the self-reliance, how to get our own products in the market. So to do that, you have to understand where we enter the market. So there are certain amount of core quantum product, IBM, the Googles, they are already selling quantum computers today. So these are core quantum products, which are the circuits. Then we also have the associated product, the quantum associated products like a dilution refrigerator, the cryogenics. These are expensive equipments. And then the third is the beyond quantum products, which are peripheral products, which means that you have to have something like a microelectronic circuits. So you see, quantum is not just about one quantum computer. There's a very large component numbers that makes a quantum computer. So what would you like to do? We would like to make businesses at small components first. For what we would see, for example, a cryogenic filter costs $370 in the market. You can make hundreds of them. You can make $1 billion business there alone, for example. So we are actually seeing that recently the quantum equipment and the accessory software companies are becoming very large. See, in 2024 alone, most of the companies that have come up are in the small component and the software region. Okay, I'm almost done. So you see, the building the ecosystem, we are taking certain strategies here. Our biggest problem is how we connect the core quantum expertise, which quantum scientists, AI and computer scientists, the quantum startups and core manufacturing of semiconductors to the peripheral workforce. By peripheral workforce, I mean those who are communication engineers, those who are polymer chemists, somebody in Pina working on mechanic shop and making compressors, for example. How do we connect the peripheral workforce with the quantum workforce? And then how we connect that to the users. For example, the biopharma industry, for example, the doctors and the surgeons in the hospitals, and how do we connect them to environmentalists and civil engineers for certain areas of their application. Most people don't even know that the quantum technologies can offer them certain amount of services that they simply cannot, that can enhance their businesses. So what we will do here, we are making a, what do you call a Qpedia. This is a structure, this is an idea that IISc is developing. Essentially, the idea is a community-driven online resource where essentially the purpose is to have a information bank for everybody, not just for the students. For even if you are from a region where you have no idea, you are a painter, can quantum technology help you? And in what way it can help you? So we are developing a resource for this where we would be looking at each and every person will be able to get enough information to how do you engage with the development of quantum technologies. That's one. And the second is we are also developing a nodal point of what we call a quantum business foundation. The idea here is that we will create a conglomerate or a consortium of startups, VCs, investors, organizations, individual entrepreneurs. Essentially, the idea here is that we would like to allow incubation of quantum and ensure that the information of these are immediately available to the VCs and others so that they can come together and develop quantum products. The reason behind it is that we don't see quantum technologies to be core of few quantum products. We see quantum technologies as a community service, as a much larger. There are small components to very large quantum computers in itself. So I would like to end this talk by showing a real gyroscope, for example, which has been installed at the Sicily Mount Etna just to measure the vibration of the Earth crust because these are volcanic zones. So you see, this is a perfect example of quantum sensing and the kind of product we can do. For example, we can measure the fluctuations in the Earth crust and see if that could be used in earthquake prediction. Can it be used in tsunami predictions and various other applications? Thank you very much for your attention.
Thank you, Professor. That was really enlightening. And may I request Drorbin to kindly come up on stage to present our token of gratitude to Professor Arindam Ghosh. And Drorbin happens to be our next speaker also, CEO at Israel Innovation Authority.
Do you have any time for questions or no? Do you have any time for questions or no? Okay, I mean, if there are questions, I'll be happy to answer.
He's ready to take one or two questions from the audience. Is there any question?
Do you want me to cue the video here? Okay. Yeah, please.
Thank you, Professor, for your talk. I got an overview of quantum technology. I have a question which is very naive. Do you think quantum technology and AI are orthogonal fields?
Sorry, say again?
Do you think quantum technology and AI are orthogonal fields?
No, no, exactly not. So great, thanks for the question. It's a wonderful question. So AI is a technology that we are seeing today. Quantum technology is essentially going to complement AI technologies in the hardware business as well as in software. So there are complementarity happens because today, many of the, as AI computation overload increases, at some point of time there would be a hybrid formation in which some of the AI tasks will simply be dumped onto a quantum computer, quantum processor, and take the results out. That's one thing. And there are many other ways AI and quantum complement enormously. For example, you can use AI to find better solutions for quantum technologies, and you can use quantum-inspired algorithms for AI applications. So AI and quantum computing are extremely intimately connected, but at the same time, we see that in the future, hybrid model is almost certain to happen.
Thank you.
We could probably take one more question. Or
if not, then I'll play a small video here about the quantum city that is coming up. I was just told about it. Is it okay? For about 1.5 seconds. You play? Okay.
Well, that was very interesting and highly inviting as well. Thank you so much, Professor Arindam Ghosh. May I now request Drorbin to kindly present our token of gratitude to Professor Arindam Ghosh. Thank you, Professor, one more time. And our next speaker will be Drorbin, on stage already, CEO, Israel Innovation Authority. Drorbin is the Chief Executive Officer of the Israel Innovation Authority, leading the country's national innovation strategy. He previously served as President and CEO of RAD and held senior global roles at Commerce alongside board positions across Israel's tech ecosystem. Warm welcome to Drorbin to present his views with